Anyone who drives a lot on gravel roads is familiar with their problems. Some roads are more susceptible to these problems than others because of deficiencies in the road's materials, the nature and extent of wear and tear by traffic, and the weather, poor geometric design, or poor grader operation during maintenance. Here in Part 2, we'll look at the 3 most common problems of gravel roads, including their causes, prevention, and correction. First, corrugation, then loss of material, and finally, rutting. Corrugations are the transverse ridges that usually extend across the full width of the traveled portion of the road, running perpendicular to the direction of traffic. In many parts of the country, this distress is also called washboarding, and it's not hard to understand why. The ridges remind you of an old washboard, both in appearance and feel. Especially feel. They'll rattle your bones and loosen your fillings. Drive on them any distance, and you'll swear that your car's coming apart bolt by bolt. And you with it. But the term corrugation is pretty descriptive too, as in corrugated paper or corrugated pipe. Regular undulations forming alternating ridges and valleys. Sounds lovely when you're thinking of the Appalachian Mountains. But it's aggravation mountains to drive on. The ridges may be as high as 50 millimeters, with less severe washboards measuring lower. The distances between ridges typically measure 150 to 200 millimeters. Corrugations can cause violent vibrations in moving vehicles and seriously decrease the driver's control of steering and braking. So we know what corrugation is, but what causes it? Well, first of all, traffic. More precisely, it's the oscillating action of vehicle suspensions and tires that forms the surface ripples. Increased vehicle speed apparently hastens and enlarges their formation. Even different tire inflation pressures seem to affect their rate of development and severity. Hard braking and quick acceleration are causes too. Wherever traffic tends to stop abruptly or start rapidly, you're likely to find washboards, such as at stop signs. Besides traffic, though, washboard formation is related to the gravel's gradation, road conditions, road locations, and even motor grader operation. In terms of the gravel's gradation, corrugations tend to form when the gravel contains too few fines. In other words, too little binder material. The fines may be insufficient either because they weren't in the gravel originally or because they had gradually dusted away or washed away. Even when the gravel's gradation is good, road conditions may not be. Excessive dryness creates dust that results in the loss of fines. Steep grades or crowns may allow fines to be washed off by rain. Either way, the loss of fines leaves the remaining gravel susceptible to washboard formation. Soft road beds and potholed surfaces encourage washboarding too. Certain locations along gravel roads are more likely to develop washboards. Intersections are prime candidates, because of traffic deceleration and acceleration, as are hills, curves, and driveways. Finally, improper motor grader operation during routine maintenance can lead to the formation of corrugations too. Operating too fast or in the wrong gear produces machine oscillation that causes the blade to leave ridges in the surface. This type of corrugation is easy to detect because the ridges are diagonal, matching the blade angle. To avoid making them, grader operators should run between 5 and 8 kilometers per hour, work in the proper gear, use the correct blade angle and pitch, and inflate their tires correctly. Now, as for preventing washboards, the only sure way is to close the road to traffic permanently. The only preventive measure you can get away with, however, is to make sure that the surfacing material has enough fines in it. Some agencies are fortunate to have gravel with adequate natural binder. Other agencies must adjust their crushing plans to process material with sufficient fines. Still others have to add extra fines to their gravel or a commercial binder such as road oil, base seal, or soil tight. Having gravel with enough fines is essential, regardless of how easy or hard it is to obtain. Of course, even with the best material, washboards tend to form in gravel roads, especially at the locations identified earlier. So what corrective measures can be employed? For light washboarding, where the corrugation heights are under 25 millimeters, routine blading or dragging will remove the problem. Motor graders are typically used to do this smoothing, but drags, rakes, and underbody truck blades may be used instead. Moderate and severe washboarding have ridges that are not only more pronounced but also more difficult to correct. Merely clipping off the high spots and filling in the low ones will not solve the problem for long, because the corrugations tend to reform at the same locations in a matter of days or even hours. Instead, scarifying and cutting the surface is first called for, to a depth just below the bottom of the corrugations. Then, adding natural or commercial binder, adding more gravel if needed, and finally, mixing the materials and reshaping the surface. Because corrugation may be concentrated at certain locations, spot correction is frequently called for. Care should always be taken to blend the corrected areas into the adjacent roadway. Correcting washboarding after rains is always a good idea, since moisture is needed to compact the regraded material and form a tight surface crust. Whether the regrading is extensive or in limited areas, the roadway crown and cross slope should be maintained everywhere, and good transition should be made at bridges and intersections. The next problem is loss of material. We're talking about aggregate material that is either removed from or displaced within the roadway. Basically, it can be lost in 3 ways: by dusting away, by raveling, and by a process we'll call sinking. Let's look at each. Dust, of course, is created by dryness, whether it's an arid region, a dry season of the year, or just a rainless spell of weather. All gravel roads produce some dust in dry conditions. Dust is created when the fines portion of the surface gravel dries and loses some of its binding qualities. Tire action breaks up the surface crust, separating the coarse and fine particles and lifting the fines as dust. While some dust settles back onto the road surface, much of it ends up on the roadside, on adjacent properties, and, of course, on the vehicles that raised it. It may be hard to imagine losing much material in these billowing dust clouds, but research shows that as much as 25 millimeters of surface material is lost each year from dusty roads, or in other terms, about 70 metric tons per kilometer. Of course, this varies with the amount of traffic on the road. Such a loss is certainly significant because that material is needed on the road. Whatever amount is lost, an equivalent amount, especially fines, needs to be put back. But the cost of replacing lost material is not the only drawback. Dust is a nuisance. It's not pleasant and it's not healthful. Property owners along dusty roads don't like what it does to their homes, crops, livestock, and businesses. Then there's the safety issue. For those who drive on dusty roads, visibility can range from poor to zero. But the problems don't even end there. It's not just the replacement cost, safety, health, and nuisance issues. Severe dust also means that the binding material is removed from the surface, leaving the remaining gravel susceptible to washboarding and a further loss of material. This further loss is what we'll call raveling. With the road's crust breaking down and too little binder remaining, the larger gravel particles loosen and separate. Traffic easily whips them out, kicking some off the road and leaving the rest displaced on the surface. Typically, this gravel accumulates along the road in longitudinal ridges that run in the direction of traffic, between wheel paths, and on the roadway edges or shoulders. Loose gravel also tends to accumulate where vehicles regularly stop or turn. Raveled material means that the road surface has broken up and isn't performing its intended function. The loose gravel also creates poor traction and steering, and often results in cracked windshields. A couple of things can speed up the process of raveling. Rainfall, for one. It further erodes the fines and washes them off the road. Also, steep grades and excessive crowns allow gravity to work with rain and tire action to further separate the loosened gravel. Finally, another form of material loss is the sinking of surface gravel into soft, excessively wet roadbeds, especially ones containing a lot of clay or silt. Field observations show that tremendous amounts of gravel can be lost into subgrades at such locations. If the situation isn't corrected, the gravel will continually have to be replaced. So how can you prevent aggregate material from being lost? Well, to prevent or at least delay dusting or raveling, be sure that new surfaces have enough binder. And try to compact them with a roller, usually after adding water, to produce a tight, impervious crust. Through time, however, the effects of weather and traffic are likely to disturb any crust, resulting in loss of fine material and eventually raveling. Corrective measures for dusty or raveled roads start with replacing the lost material. Fines often can be reclaimed from the shoulder edge and regraded and mixed with the existing gravel. This operation should be done as routine maintenance along with restoring the road's crown. Basically, however, dust is effectively combated only by adding something to the road surface. Palliatives or dust suppressants are needed. Water is the simplest and most environmentally acceptable suppressant. But you can't always count on nature to apply it when needed. And for maintenance crews to apply it, the amounts needed and the equipment and worker allocations required make it prohibitive. so commercially available suppressants make more sense. They include calcium chloride, magnesium chloride, resin products, enzyme products, salt, cement, and other agents. Their use is cost-effective when the amount of traffic on a road is high. These palliatives suppress dust by helping the gravel particles bond together, not allowing the fines to be picked up by traffic and raised as dust. Chloride products, for example, attract moisture, absorbing more than their weight in water. This retained moisture holds the gravel particles together. The difference between treated and untreated surfaces can be remarkable, as you see here. Prior to applying any palliative for the first time, it should first be tested by constructing a test strip on the road to be treated. Recommended application rates and procedures should be followed, and the results should be carefully noted. The handbook contains more information about palliatives. Next, the loss of sinking gravel can be prevented by making sure that subgrade materials and conditions are good when the road is constructed or re-graveled. Otherwise, muck or other poor roadbed materials will soon begin swallowing up the surface gravel. Another preventive measure is to provide adequate drainage. Of course, that's easier said than done. In some places, in some seasons, it's nearly impossible to keep roadbeds dry enough. But to stand a chance, roads have to be constructed and maintained to keep water off, out of, and away from them. To correct the effects of habitually wet and unstable sections of road, geotextile materials may be installed between the problem roadbed layer and the gravel surface. The handbook discusses this type of solution. Finally, let's look at rutting. The condition that leads to the material loss just described results in another type of gravel road problem, rutting, and, to a related problem, potholes. Ruts are longitudinal depressions that form in wheel paths due to a permanent deformation in any road layer or the subgrade. They create an uncomfortable, perhaps treacherous, riding surface, and they lead to further deterioration of the road. Slight rutting may be due to normal traffic wear on the gravel surface. Ruts may also be created where some of the surface gravel is dislodged. With wet roads, though, rutting often becomes severe, all the more so when the roadbed has a high clay or silt content, or when it has excessive fines. In the case of high clay content, here's what happens. The live loads exerted by traffic on the wet road cause the water and clay to mix and form a paste. Traffic also creates a suction that pulls the paste upwards into the surface course. Normally, in dry conditions, the gravel particles hold firmly together by friction. But when the clay paste is pumped up from the base into the surface, it coats the gravel. The particles become lubricated and lose their friction, allowing their surfaces to slide past each other. So as the gravel is pushed down into soft, wet material below, severe ruts develop above. Now, the wet conditions that contribute to rutting may be caused by inadequate roadside ditches, poor crown, weak roadbed soils, or a high water table. Potholes are related to ruts, bowl-shaped depressions usually less than a meter in diameter. They are produced where traffic wears away small areas of the road surface or where soft spots develop in underlying soils. Water or excessive fines in the road contribute to pothole formation. And potholes grow faster when water sits in them. The problem becomes severe when potholes cover most of the road surface. The best way to prevent serious rutting is to maintain the road's crown, ditches, and culverts properly, assuming that the subgrade doesn't consist of soils that are weak even when dry. As for correcting rutting, slight to moderate rutting can be corrected by blading the surface and restoring the crown. Severe rutting often calls again for improving the road's drainage. So cut ditches and install culverts, or clean or replace existing ones as necessary. And just as with sinking gravel, severe rutting may also be related to subgrade conditions. Excavation into the roadbed and replacement of existing foundation soils with more stable free draining materials may be required. Once drainage and roadbed problems are solved, new gravel should be added to the surface and properly shaped. Another possible solution is to add materials such as dust palliatives to stabilize the existing gravel. As for potholes, isolated ones can be repaired by hand, by cleaning up the depression, filling it with well-graded granular material, and then compacting the patch. Extensive potholes require reworking and major regrading, usually preceded by scarifying. Well-graded granular material is often added. The scarification beforehand ensures a good blend of the existing material with the new. But even when new material is not added, the scarifying is needed to form a new crust. In the process, moisture may have to be added, and the road may need reshaping to restore the crown. Drainage improvements will likely be needed too, to restore surface stability and prevent future potholing. Potholes, ruts, gravel lost by sinking, raveling, or dusting. Washboards. These are common problems of gravel surfaced roads. You're now familiar with what causes them and how to prevent or correct them. In Part 3, we'll look at maintenance equipment and techniques.